Hey guys, I'm Florian. I'm president of Dynamic AI, as you heard. Today I will guide you through our journey of the last 5 years, from about AI for automated business communication, from research to production, how the AWS platform helped us to start from zero in the fly. No deep learning genetic coding. I emphasize genetic coding as we approached the current general approach regarding AI, and I will show you this later. So, the presentation is structured in the following way. First, I show you a snapshot about the business need, why we do what we do. Secondly, I show you the start from the research in 2015 till today to the production. And thirdly, before we go to summaries and takeaways, I give you some insights about our technology in more depth. And then at the very end, we go to demo. We have snapshots from live demos in the last 3 weeks from enterprise companies out of the Fortune 500, so that you really see it works. So, why we do what we do? According to Forbes, 85% of business communication, like customer care, HR, finance, ops, and much more, via email, chat, messaging, is repetitive, time-consuming, costly, but imperative for enterprise success. Take, for example, Southwestern Airlines. They have 90,000 messages via Facebook and Twitter, and they really take it serious about the brand. What do? We dynamically automate up to 80% of the business communication in real time. That means incoming emails, chats, and we also automate as we understand what these people are writing in the different intents, in the different sentiments. If they complain, if they want to rebook, all these things. We really understand this. And we can act based on this in a CRM or in any other database. And what's the really nice part of us? We learn. We learn from new messages. We get better over time. And some stats just that you better understand the business need. In 2019, we have roughly 300 billion emails a day, and that grows by 5%. Another figure, for example, is the number of messaging users. In 2019, it was 2.2 billion. It's growing by 7%. A lot of companies are moving more and more to these chat and messaging apps to contact with their customers, or also with employees. Slack, for example. I think most of you know it. So, here you see, on the right side, the architecture of our first approach in 2015. It's the most common, most classical approach everybody knows in AI. Yeah? It's just classification. Yeah? So, we started with outbound sales, as we were an agency at the time to fund ourselves. We also did some support, and we did it by email, to shoot out, boom, at what comes back. Yeah? What comes back is mostly then something like, yes, I'm interested, no, I'm not interested, go to hell, blah, 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 blah. Yeah? Many categories. We said 10 categories, enough more is not doable at the time. We did it in English and in German, of course. And we used 7 ML models. We used artificial neural networks, we used long short-term theorem, CNN, and so on and so on. Yeah? I think everybody here knows it. There were general approaches. If you know about deep learning, you need for each category, and this is a very important number which you should remember then regarding genetic coding, at least 1,000 data points, means messages, to start learning. And I will show you that we do it with much less. So, first feedback and outcomes. So our first trial showed us businesses require high precision, 95% plus. That's almost a human being. That was at the time not possible. And I'll show you later why. Data security. For big companies, it's super important that the data doesn't go outside. I think we all know now in the last 18 months with Facebook and that stuff, that data privacy is very important. Next, some interesting points. The first 10 is 10 machine learning models, as you showed before, for every category. That's a lot for high precision, but it was not 95%. Secondly, we used 10 plus categories for the customers we were working with regarding outbound sales agency. Yeah? And if you go from the special case for one customer now to a general approach that you want to do this for every customer, yeah? Then you need 1,000 plus categories, as well as more machine learning models. It's crazy. It's manually, it's not possible. You have to assume that when Southwestern, for example, says, OK, we make space flights, you have to manually prepare the data in the categories. Yeah? That's crazy work if you assume 90,000 messages per month were of social media. So, on the way to semantic similarity linguistics. I think most of you know NLP, natural language processing. This is the first approach you have to do to understand language, linguistics, English mostly, what we use here. And very common libraries, I think, everybody knows Stanford, LTK, Spacey. They are all very good, but they don't have a common framework together. That means everybody understands language differently, and I'll show you later why. And also then the results in the corpus, in the emails, they were different, because a different understanding of synonyms, of slang, idioms. Yeah? PLS for please, RE, or Mr. Thompson. Mr. is it first name? Or is it just which gender this person has? Yeah? So you see, there are challenges in the language which have to be solved also by mathematics. What you see here is also what we use then for the semantic similarity search. It's the strongest engine you can find on AWS is AX1, and we really needed this to get the best out of it. Yeah? This is here in the solution. It was from highly importance that we have cloud resources because we couldn't do it with on-premise solutions as we had it. So, linguistics. Here, what I mentioned before, language is very complex. Every person, every organization, every industry understands the same text differently. I really want to give you this. This was one of the biggest findings. Yeah? They are really good in detection in the entities, all these various providers, but as you can see, only 82 to 86% precision. This is too little for a professional company. Won't work. And a lot of noise also in the machine learning models, so very complex and absolutely static, not dynamic. And a good example, for example, is at the hotel, at my hotel, near hotel. It should be somewhere around the hotel, but where exactly is it? Also then, let's have half a pint of beer today, 1 backslash 2. The engine also has to understand, the algorithm has to understand what is this, and gets it from the NLP library. It's super challenging. So, as mentioned, similarity, precision, these were the challenges which we have to tackle. And we really had to automate it and to make it dynamically without human interactions. So what we did was use ML to understand the results from NLP best. And to do so, we used auto machine learning to fine-tune this. And via fine-tuning, we got better precisions out of the models which we were using. And similarity search also became better over time. Nevertheless, we had to go one step further. It was not enough. We still were static. And this was the point where my partner Roman, he is also here today. He's the nice, good-looking guy there. He had this idea regarding genetic coding. Genetic coding is a code of codes, to keep it simple. It comes from mathematics, from evolution algorithm. And these codes produce your codes which are the best fit for your issues in NLP, to keep it simple and short. And Roman also wrote, I think, 50 pages of a patent at the USPTO. So it's really our IP. It's not from Google or Microsoft. But of course, we're working with TensorFlow, to be honest. And with this tool, we were really able to come up to 80% of automation of these emails which were coming in. And I know this sounds now really a little bit crazy, but it's working. It's working great, and we have also some live shots from our online demos. And you can see we really meet with the system data security requirements, adaptability for changing traffic, NLP and language independent core algorithm, because we have so many channels nowadays. We have email, we have Facebook, we have Twitter, and we have all different CRMs. You have Salesforce, you have Microsoft Dynamics, SAP, and so on and so on. Putting our approach into a new perspective is that we turned the game completely around, about 180 degrees. And everything with the help of AWS, to be honest. So what we do is we really connect and automate the business communication in these different industries and different channels, together with this manual work also in the whole databases, like the CRMs. And we don't compete with chatbots and RPAs, which are completely artificial, because we mirror people and we really go into the repetitive human work. This is the message I really want to give you. So, and now I really want to show you a proof of concept that it really works, and then you see it by yourself. So, how does it work to push on the video? Do we have sound?
So here is configuration monitoring web interface, which has some graphs. You can add, for example, new sources of messages. You can choose mail as a service provider, mail like Twitter and so on. You can choose some filters for the messages. Also, you can specify what to do with those messages. For example, create draft, use semantic search. You can control precision and so on. You can use additional options like schedule and so on. And also you can specify which groups would be processed by which actions. So these settings are available also through the API.
Next point, just to give you a big picture how our system works, this AI process automation for business communication. The thing is, you have the company in the middle. I mean, doesn't matter if it's a US government agency or it's AT&T or Microsoft, all these entities have communications with external, internal people like customers, prospects, employees, vendors, whatever, yeah? Ask you now, you see now my inboxes, my private inbox. As you can see, I've already booked my flight back to LA for my family. Mm-hmm. And here is the live demo inbox, which we prepared. It's 237 messages, yeah? So 5.4, yeah? And as you can see, we have trained it on this cancel, invoice, pay problem, yeah? And logistics, whatever, yeah? So this is what we have trained now according to the 7 categories. And I would say I make now 2 messages that you get somehow a feeling. And from there on, we try something new together. Florian, yeah? This is now the invoice things, I send it now.
So Florian, does punctuation matter?
We train it from your data. Basically, it's now pre-trained brain, but for real client, we fully retrained brain with mistakes. What has this client with problems with words, with all of these issues. So basically, real language very bad. It's very bad for understand with NLP stack. And we understand text. We don't understand some sentences. We understand structure of text, meaning of this, and mistakes system understand too, basically.
So what we drafted now, after 13.8 seconds, what the system understood was, if you look down here, similarity check, what the system is invoice 10.2, scoring, invoice 22, similarity check 9 points, invoice 18. So you see there's a high confidence that it's an invoice topic. Yeah,
it's other messages from current mailbox, from demo mailbox.
I understand. So, it's trying to start to build the correlations and narrow it down.
Yeah.
Exactly.
And basically, system use a top message to make new draft for you. So your system don't need templates. System using your data. So
are we at the point in the process now where we already have 243 related messages, or are we still building the 243?
The thing is, we have in total this 240 messages plus minus, yeah? And we have the 7 categories. Because these were the categories where we said, okay, companies like Southwestern, they have 90,000 messages via Facebook and Twitter for customer care only on a monthly basis.
Right.
So the more data, the better. And we take the best and the most fitting ones.
Okay.
Just let me this finish. Accident that it works. Also, as you can see here, 13.2 seconds. It's got the right draft because it's what we prepared. Stop, blah, blah, blah. Yeah, this you can put it as you want. You can forward it to the right person. You can call this person back, whatever. Yeah. Now I want to show you how the system learns. And this is something we want to show you as a last point. I think we do something by now. I think the Easter vacations are starting for most of the people, spring break.
So basically, you now see how system learning in real time. If your employee sends this draft or add minimal change, system will understand this, and next it's knowledge base for system.
Okay, got it.
So
This is really cool to see this. So,
Model work.
yeah, I like this demo a lot. This is really cool to do it in real time and from address too. You can see all his emails.
For real company, we have some conditions where system working only with good precision.
And you say everything below this 95%, it has to go to customer care agent, and he has to cross-check, and he can real-time correct the draft, for example.
Right. Oh, and then the system can learn from.
And after 15 minutes, for example, after 4-10 messages, system will understand and in real time start to help to your employee.
I sent now 2 other ones, because...
So you mentioned the knowledge base. So is it extracting, processing the text and extracting into like the three paired, key value paired knowledge base? That's okay.
Knowledge base, it's a data where we have incoming text and we have some actions from your employee. Maybe it's response, maybe it's response with data from CRM, maybe it's actions only with CRM. This pair is part of knowledge base.
Can you see this? It's the third message.
Okay.
And it already got it after the third message. You see?
And look at the different points.
And you see it in Easter offers. So after the first 2 ones, and it was really high scoring, So it really got the first 2 ones, Easter offers, and then exit ended. Similarity check. You really can see this, yeah?
Just to finalize my argument, to summarize certain takeaways from you. These were live demos, as mentioned before, with Fortune 500 companies. It was simple. As you saw, the system learned in real time after 3 messages, compared to deep learning with 1,000 messages per category, what I told you. So what I want to tell you and want to give you for the weekend, already on Thursday, is that currently, everybody knows these RPAs, bots, who are classifying, But there's also a new category who's understanding and acting and learning based on the information it gets in real time.